India is leading the global clean energy transition. Discover how grid-integrated hybrid renewable energy systems are powering our nation's future while drastically reducing carbon emissions. In this episode of Consumer Times, we explore the innovative strategies combining solar, wind, and battery storage that are transforming India's energy landscape. Hello and welcome to Consumer Times. Today we are diving into one of the most critical topics for India's future: sustainable clean and green energy solutions through grid-integrated hybrid renewable energy systems. As consumers, understanding this energy revolution isn't just about environmental responsibility. It's about recognizing how these changes directly impact your electricity bills, energy security, and the air you breathe. So let's explore how India is pioneering a strategy that's transforming the global energy landscape. India has achieved something extraordinary in 2025. The nation reached 50% of its installed power generation capacity from non-fossil fuel sources, accomplishing this milestone 5 years ahead of its 2030 Paris Agreement target. With a total installed capacity of approximately 510 gigawatts, comprising 262 gigawatts from non-fossil fuel sources, India now ranks fourth globally in renewable energy capacity. This isn't just a statistic, it's a fundamental shift in how we power our homes, businesses, and industries. So what exactly are grid-integrated hybrid renewable energy systems? Think of them as intelligent energy ecosystems that combine multiple renewable sources, primarily solar and wind, with battery storage, all seamlessly connected to the main electricity grid. The genius of this approach lies in complementarity. Solar panels generate maximum electricity during sunny daytime hours when wind speeds are typically lower. Conversely, wind turbines often produce more power during evenings and nights when solar generation drops. By integrating these sources together, we achieve more consistent and reliable power generation throughout the day. Wind and solar energy resources are complementary on a diurnal basis, with peak wind times occurring after sunset and before sunrise, while peak solar times align with periods of lower wind resource. This natural balance reduces the intermittency problem that has historically challenged renewable energy adoption. When combined with battery energy storage systems, excess power generated during peak production hours can be stored and released during high demand periods, ensuring grid stability and continuous electricity supply. The integration architecture itself comes in two primary configurations. DC coupling topology connects solar panels, wind turbines, and batteries on the direct current side before converting to alternating current for grid distribution. This approach offers simplified hardware, lower costs, and higher energy efficiency. AC coupling, on the other hand, connects each component independently to the grid through separate inverters, providing greater flexibility for system expansion and maintenance. The choice between these configurations depends on specific site characteristics, resource availability, and economic considerations. India's remarkable progress didn't happen by accident. In 2025, the country added around 50 gigawatts of renewable energy capacity, backed by investments of nearly 2 trillion rupees. Government initiatives like the PM Surya Ghar scheme, which aims to provide free electricity from rooftop solar to 10 million households, and the National Wind-Solar Hybrid Policy have accelerated deployment across states. States like Gujarat, Rajasthan, Tamil Nadu, Karnataka, and Maharashtra are leading this transformation with ambitious targets and dedicated renewable energy parks. The carbon footprint reduction achieved through these hybrid systems is substantial. India has committed to reducing carbon dioxide emissions by 1 billion tons by 2030 and decreasing carbon intensity by over 45% compared to 2005 levels. As of 2020, India had already reduced emissions intensity by 36%, putting the country ahead of its projected trajectory. These reductions translate into tangible health benefits. Cleaner air means fewer respiratory diseases, reduced healthcare costs, and improved quality of life for millions of citizens. Energy storage technology has become the linchpin of successful grid integration. Recent renewable energy tenders now prioritize hybrid and dispatch-able power, integrating battery energy storage systems at both grid and project levels. Modern lithium-ion batteries and emerging technologies like flow batteries enable utilities to store excess renewable energy and dispatch it precisely when needed, maintaining grid frequency and voltage stability. States like Karnataka have already floated tenders combining solar capacity with gigawatt-scale battery projects, ensuring round-the-clock renewable power supply. The economic case for hybrid systems has become increasingly compelling. Level Z cost of energy from solar and wind has dropped dramatically, making renewables cheaper than new coal power plants in most locations. The production-linked incentive scheme, domestic content requirements, and transparent bidding processes have boosted local manufacturing, creating jobs while reducing import dependency. India now manufactures much of its solar equipment domestically and is emerging as a net exporter of wind generators. However, challenges remain. Grid infrastructure must be upgraded to handle bidirectional power flows and distributed generation patterns. Transmission capacity additions sometimes lag behind renewable project commissioning, causing temporary curtailment. Land acquisition, right-of-way issues, and power purchase agreement negotiations can delay projects. The continued reliance on coal for baseload power, while declining, still presents obstacles to faster decarbonization. Looking ahead, India's energy roadmap includes several breakthrough initiatives. The National Green Hydrogen Mission, with a budget allocation of nearly 20,000 crore rupees, is commissioning projects that will use renewable electricity to produce carbon-free hydrogen for industrial applications. Offshore wind development, pumped hydro storage, and agrovoltaic systems that combine agriculture with solar generation are expanding the renewable energy toolkit. The operationalization of the Indian carbon market in 2025 provides market-based mechanisms for emissions reduction, with mandatory caps for carbon-intensive industries. For consumers, this energy transition means greater energy independence, reduced vulnerability to fossil fuel price volatility, and cleaner power at competitive rates. As grid-integrated hybrid systems proliferate, expect more stable electricity supply, lower tariffs over time, and new opportunities like rooftop solar installations with net metering that can reduce your monthly bills. India's clean energy revolution demonstrates that economic development and environmental sustainability can advance together. The grid-integrated hybrid approach provides a replicable model for other developing nations facing similar energy challenges. As consumers and citizens, understanding these systems empowers us to make informed